Dear students, you are welcome in this class. I am Dr. Dinesh Kumar, Principal Scientist in Division of Agronomy, IERA, New Delhi. Now we are going to discuss an important topic, soil fertility decline and its restoration. By now you understand what is soil fertility, what is meant by it, and today we will see what is soil fertility decline. In the last lecture, you have seen the status of fertility in India, and you have seen other details, like you have seen the status of carbon, nitrogen, phosphorus, micronutrients in India. And you have seen under most of the cases, the fertility levels were low. So fertility is actually cumulative of all these properties, physical, biological, and chemical property. And mainly people take chemical fertility. If you take chemical fertility, then if your pH is wrong, it is not ideal, optimum, then you can say fertility has gone down. If your cation exchange capacity is getting low, humus content is getting low, or your nutrient content is getting low, that means you can say that your fertility is declining. So you have seen overall that in many districts or many states, the nitrogen was universally absent, or not absent, was deficient. You have seen micronutrients like zinc was deficient in 40 to 42% soil. Nitrogen was universally deficient in soils. So there were few nutrients which were having a good level in certain soils. Organic carbon, see in this Indo-Gangetic belts, particularly Punjab, Haryana, Western UP, etc. There was 100% soils were deficient in carbon. So you have seen the status of soil fertility in India. That means the levels are going down. The soil fertility is going down. Now today we are going to see the reasons why soil fertility is going down and what are the reasons and how it can be restored. So today we will discuss the reasons for decline of soil fertility and describe the strategies to overcome this decline. So how we can overcome this, and then certain terminology. Acidification of soil is also a soil fertility decline. Similarly, alkalization. So acidification is the process of becoming more acid or more acidic. Similarly, if it is becoming more alkaline, then it is alkalization. Ammonia volatilization, gaseous loss of nitrogen in the form of ammonia. Crop rotation is a plant sequence of growing different crops in the same field over a fixed period of time. Denitrification is an anaerobic process in which soil nitrates are converted into gaseous compounds, that is nitrogen oxides or nitrous oxide, and maybe this gaseous form, N2. Then some more words like minimum tillage is the minimum amount of cultivation. So tillage is almost synonymous to cultivation, to plow the land normally. So the minimum amount of cultivation to prepare a suitable seed bed. Purpose is to reduce energy consumption, conserve moisture, and retain plant cover to minimize soil erosion. That is your minimum tillage. Salinization is the accumulation of soluble salts at the surface or below the surface of soil profile to levels that have negative effect on plant growth. Soil erosion is the detachment, transport, and deposition of soil particle from one place to another place. You can remember very easy definition of soil erosion. Detachment, transport, and accumulation or deposition of soil particle from one place to another place is known as soil erosion. Now, what is decline in soil fertility, or what is decrease in soil fertility or reduction in soil fertility? You can use several terms, or you can say why the fertility gets deteriorated. So deterioration, reduction, decline, etc. words can be used for soil fertility decline. So normally people use decline. So decline particularly in chemical, suppose chemical soil fertility means decrease in soil organic matter, decrease in cation exchange capacity or plant nutrients, or changes in adverse soil pH. So this is your decline in soil fertility, or particularly chemical soil fertility. If you see biological soil fertility, decline in biological soil fertility means reduced growth of microbes and other kind of organisms in the soil. Means biological, whatever organisms are living in soil, their number and their size gets reduced. That is also fertility decline, but that is biological fertility decline. Similarly, physical soil fertility decline can be there. Physical soil fertility decline means your soil compaction can be there, water logging can be there, or there may be degradation of soil structure. So number of physical properties can be deteriorated. That is also physical soil fertility decline. But what will happen if all the three properties gets declined? Chemical fertility, biological fertility, and your physical fertility, all three can also go down because one is dependent upon other. If your biological fertility goes down, means your organic matter is also going down, microbes count is also going down. So that means your soil structure will be affected. Soil structure can be reduced or can decline because many properties or many characteristics are interdependent. So therefore, you can clearly understand what is soil fertility decline. Here, I'm mostly restricting to the chemical soil fertility decline. So decrease in soil organic matter, cation exchange capacity, plant nutrient status, and adverse soil pH. So normally in testing, in soil testing, and what you are seeing in the soil health scheme, more thrust is being given on chemical fertility of the soil, on the nutrient status. In chemical fertility, they are not giving much emphasis on cation exchange capacity or biological fertility, etc. So soil fertility decline thus includes. What is included? Here, just see that it is mostly chemical soil fertility. So there are two terms. One is nutrient depletion and other is nutrient mining. So many times students take them synonymous, but they are not synonymous. Nutrient depletion is larger removal than addition of the nutrient. You are adding some nutrients, but you are not adding nutrients equal to what has been removed. So removal is more than the addition. A negative balance of nutrients happen. That is your nutrient depletion. In nutrient mining means large removal of nutrients and no inputs. You are not adding anything. You are just removing whatever is there in the soil. That is known as nutrient mining. So mining also you understand in other areas like coal mining or mining of other minerals. So in that case, you are just taking them out from the mines and you will never give back coal to the mines. Whatever coal is extracted from the mines, that will never be returned to the mines. Similarly, whatever nutrients you remove from the soil that are never returned to the soil by man, that is your no input. And just removal is your nutrient mining. There may be acidification or alkalization. You understand the reasons why acidification happens, why alkalization happens. This is not part of this course. You can understand from the Brady's book what is acidification. Loss of soil organic matter is another serious issue. You have seen in India, many soils are getting organic matter levels depleted. Or organic matter content is declining. Increasing toxic elements, very few studies are there, but you can guess that our soils are getting polluted due to several reasons. You will see why soils are getting polluted. Increase in toxic elements and soil pollutants like pesticides or heavy metals can come. And we will see what these pollutants will do to the soil. So overall, you have seen the kind of decline is happening and what it is included. So now you see soil fertility decline, the reasons, the causes. Number one cause, Loss of topsoil by erosion. So erosion is a continuous process. It is happening around us, and it is difficult to completely stop erosion. Nutrient depletion and mining is happening. Physical degradation of soil. So poor structure, compaction, crusting, and waterlogging. And then decrease in organic matter and soil bioactivity or soil microbial activity. Loss of nutrients through various routes. Soil acidification, salinization, and alkalinization, inefficient soil management, and soil pollution. So these are the important reasons or causes of decline in soil fertility. Now, loss of topsoil by erosion. This is very important because in erosion, it is mostly topsoil is eroded. And in erosion, you see if it is water erosion. Water erosion, initially, it is sheet erosion. The small sheet is removed, and farmers would not know that their sheet of soil has been removed. They will only know when it will go to the advanced stage, that is real stage. And then real stage will go to another next higher level of stage. What is that? Sheet erosion, real erosion, and then
Gully
erosion. Then
ravine is there.
I think you need to study a lot. You are quite young, just 2022, and you are not, I feel that you need to study more. Self-study is necessary for all of you. These are very simple things. So anyway, so you can imagine that our topsoil is rich in organic matter. It is rich in nitrogen and rich in microbes and rich in other organisms, rich in humus also. So if top layer is removed, your fertility is removed. So in all the conditions, erosion is there. Somewhere it is by wind, somewhere it is by water. So topsoil is rich in nutrients, microbes, and organic matter. So if erosion is there by wind or water, you lose topsoil and a lot of nutrients are lost. Not only this, the nutrients which are lost from here, they will be accumulating in water bodies, and where they can reach to lakes, they can reach to pond or rivers or oceans. And there they can cause algal growth, which is known as eutrophication. Algal blooms and eutrophication. Eutrophication is enrichment of water bodies by some algae growth. And this is very dangerous because many times this results in death of fishes and other aquatic animals because of production of carbon dioxide and going to the water, and they consume the oxygen. Therefore, death of many aquatic animals can occur. So erosion is leading to multifarious problems, many problems, not just losing soil, but it is affecting other ecosystems. So soil erosion chiefly results in undesirable human activity. What are the causes? We need to understand so that we can go for prevention of soil erosion. Cutting of forests, uncontrolled grazing, animal and inefficient management of soil. So if you know the reasons for soil erosion, you can overcome those problems, try to solve those problems. Now, next problem is nutrient depletion and mining, presently becoming an important limitation in intensive cropping system. It is always there. Farmers normally don't go for soil testing. They never apply, or they generally do not apply nutrients based upon the recommendation. They apply at their own. If it is available, they will apply. If it is not available, they will not apply. And many times, if you know the consumption ratio of NPK fertilizer in India, it is more in favor of nitrogen. Sometimes it was very, very high in favor of nitrogen in Punjab. It has reached sometimes to 32:9:1. 32:9:1. Otherwise, it has to be 4:2:1. So accelerated by imbalanced fertilization. Imbalanced fertilization is more dangerous than no fertilization. This is important. Why it is so? For example, if you are using more of nitrogen and less of P and K, so what happens? It removes proportionate amount of phosphorus and potash from the soil, and soil becomes very quickly barren. But if you do not apply any nutrient, NPK will be removed in almost same ratio. It will not exhaust your phosphorus and potassium. But in another case where you use more nitrogen, it will exhaust, soil will be exhausted from P and K, and which you will not apply. More pronounced in the case of NPK sulfur, the problem is more prominent in the areas where high yielding varieties. Intensive cropping, you get more depletion and more mining of the nutrients. And you can see in this picture, nutrient mining or depletion kind of things. So on the left side, top picture, you can see increased crop yields, intensive cropping. They require more nutrients, more and more nutrients are required. Why more and more nutrients are required? Because in intensive cropping areas, they are mostly taking cereal crops, rice, wheat, maize, sorghum, pulp millet, etc., and other commercial crops like sugarcane, potato, etc. They remove large quantity of nutrients. For example, in cereal grain, you can see to produce 1 ton of cereal grain, you need 20 to 27 kg of nitrogen. Suppose rice or wheat yield is say 5 tons, then you multiply 5 with this 20 to 27, then it will be somewhere around more than 100 kg nitrogen per hectare will be removed. So, but this is per kg, per ton grain. 10 to 29 kg P2O5 per ton grain, 22 to 48 kg K2O per ton grain. So these are a large amount of nutrients are removed, and sizable amount of secondary and micronutrients, sulfur and your zinc, iron, etc. are also removed. So you can see in intensive cropping system, very large quantity of nutrients are removed. But so far, return is concerned, return is less than what is removed, that is nutrient depletion. So thus many soils are unable to supply the nutrients and need for external inputs, you need to apply more, and otherwise decline in soil fertility. Now, physical degradation of soil can happen, broken soil structure, mainly because of too much of plowing or too much of traffic, cultivation traffic. Induced compaction can also be there, and they are related to each other. When you break the structure, when you press the soil more, compaction will occur, and with the result, the structure will be broken. Sometimes crusting can also happen, and undesirable waterlogging reduces soil fertility. So you need to learn these physical properties of the soil in detail from any standard textbook of soil science. What is compaction, how it happens, crusting, waterlogging. You are interested, I can take extra lecture, but you need to make a demand. Soil structure may change with management practices also, like your conventional cropping or more tillage or poor crop rotations. Excessive soil tillage may be responsible for deterioration of soil structure. Soil compaction reduces large pores and adversely affects aeration and root growth by soil compaction. Soil organic matter content is also decreasing. You are seeing the data of India and state-wise also. And so is the case of soil bioactivity, biological activity. So declined level of soil organic matter, decline in soil properties. Surely, because organic matter is the key in soil fertility, and it will affect your physical, chemical, and biological properties of the soil. Now, I put a question forward, and you should try to answer why the levels of organic matter, soil organic matter are declining in India or elsewhere also. In many places, organic matter levels are declining. I request you to give answer, fast answer, quick answer. Why there are declining levels of soil organic matter?
Sir, there are many reasons, but mainly reason is imbalance use of fertilizer, means very high use of that commercial fertilizer without using any farmyard manure or green manuring, composting, and another reason is that we are using that fertilizer in a tropical country where the decomposition rate is also higher. So that's the reason for why for this organic content is reducing. And as per the National Rainfall Area Authority has reported give a report where they mentioned that soil organic matter status of India has drastically reduced from 1% to 0.3% in 2022.
Very good. So there could be many reasons for decrease in soil organic matter, and it declines mainly because of erosion is one reason, accelerated decomposition by high temperature and moisture. These days you are experiencing some global warming also, so it may have some effect. Of course, that effect is not measured, but these changes will have some effect on soil organic matter. Besides this, there may be some areas like Punjab, Haryana, where the mechanization has increased. Mechanization has increased, and increased mechanization means they will keep less farm animals on their farm. So decreased number of farm animal may be there in many cases, and they will not have dung and farmyard manure. So that could also subscribe to the reduced level, because they will not add. If they do not have animals, they do not produce dung. How can they produce the farmyard manure? So in some areas, that is also a reason. And same farmers are also burning residues. So if you are burning organic matter, you have no choice. Where from will you bring organic matter to increase your soil organic matter? So those reasons can also be added to it. And when soils are tilled, soil organic matter decomposes faster than no-till condition. So in conventional farming, you get very fast. Activities of soil microbes declining if soil organic matter declines. Now you can see the inputs and output. Inputs are with plus sign and output is with minus sign. So inputs can be animal, plant manures, crop residues, litter, roots, stubbles, mulches, and root exudates. So these are the sources of organic matter in soil. And outputs, these losses, how they are lost. Soil erosion is the major loss mechanism of organic matter. Decomposition, of course, if organic matter is, it will decompose. And the speed of decomposition may vary from one climate to another climate and conditions. And leaching of dissolved organic carbon. So these are the means by which we lose organic matter. So you need to see the balance. If balance is towards left side, then you will not worry. If balance is towards the right side, means you get more losses than the more input, then you will have loss or decrease in organic. Loss of nutrients through various routes like leaching, percolation losses are there, and you can get volatilization losses, denitrification losses. So variety of losses are there, particularly in case of nitrogen. Nitrogen is mostly lost as nitrate. Can it be lost as ammonium? Nitrogen, I made a statement that nitrogen is lost by nitrate leaching. Can ammonium also be lost by leaching? Ammonical ions can be leached by leaching, yes or no? Any student?
No, sir. No, sir.
No, sir. Okay. What about other students?
No, sir.
No,
Sir,
sir.
there can be concentration loss of
So
ammonia,
as on today, I
But
go. Yes.
not leaching.
Yeah, very good. Because what happens, they are positively charged. They are positively charged and they are attached to clay colloids and humus colloids. So they are not easily lost by leaching. But what will happen if your cation exchange capacity is low and your production of ammonium is more? What will happen under those conditions? Leaching will happen. So now today you change your opinion. This is your homework. You Google ammonium leaching and you will find thousands of papers. Today you are thinking it is just nitrate leaching. And tomorrow you will say to me, sir, ammonium leaching is also there. So it depends upon the holding, this cation holding capacity of the soil. So you can check it. So it is not just nitrate leaching, ammonium leaching also occurs. And you need to study yourself under what conditions you can get ammonium leaching. So excess rainfall irrigation may result in deep percolation, carrying soluble nutrients like sulfates, nitrate, and boron. And now you can also add ammonium. Soil acidification, salinization, and alkalinization. So these I'm not going to the detail, the reasons for acidification, salinization, but they deteriorate the soil fertility. If your pH is too acidic, many nutrients will become unavailable. If it is too alkaline, many nutrients will become unavailable. And it will affect the plant growth directly also. Acids can directly inhibit the plant growth. Similarly, at high pH, certain bases can inhibit the plant growth directly and indirectly by reducing the supply of the nutrients. So nutrient deficiencies and toxicities can happen due to acidification, salinization, and alkalinization besides their direct effects. So overall, such chemical degradation of soil reduces fertility. Pollution. So judicious application of chemicals or entry of heavy metals reduces soil fertility. So means overall these chemicals or pollution will result in reduced fertility, also by reducing the activity of the soil organism. This is how it can happen. I have already discussed this table with Subhranshu, and others can also see this soil pollution. So soil pollution is done by pollutants. So where from these, what are the pollutants? First you see the pollutants, heavy metals and their salts, aluminum, arsenic, beryllium, and fluorine, fluorine, etc. Radionuclides plus many more. So these are the pollutants, nature of pollutants. And what are the sources of these pollutants? See carefully. Sources can be parent materials, atmospheric deposits, fertilizers, particularly rock phosphate, manure and pesticides can be source of pollutants. Municipal waste and sewage sludge can be sources, and many more sources can be there causing soil pollution. And how these pollutants will affect the soil. Effect of pollutants on soil or pollution on soil, they affect some physical, chemical, and biological properties of the soil. You can go into the detail how these pollutants will affect the physical, chemical, and biological properties of the soil. In total, they will reduce the soil fertility, and they can directly affect the plant growth. Effect on plants. Plant growth may be adversely affected by pollutants. Some can be poisonous, some can be toxic, and some can compete with the uptake of other nutrients. Effect on humans and animals. Food products may not be safe. They may be removed by the plant, heavy metals, if they are in the soil. So they may reach the food chain and they can affect the human health adversely. Then what is required? Go for monitoring. Observe whether your soil is having pollutant. What is the level of pollution, and up to what are the pollutants, what are the sources, so that preventive measures can be adopted. So monitoring is necessary. Physical, chemical, and biological methods. Number of methods are available to see the status of pollutants in the soil. So monitoring is required. And finally, remediation. You need to overcome this problem. So there are many methods. Prevention and many other approaches are there for reducing soil pollution. But there are certain approaches like related approaches, soil-related approaches, water and soil organic management. The number of approaches are there. You can go into the details, bioremediation, phytoremediation, and so on. One option is addition of organic matter, extra organic matter. And we will see how this soil organic matter will reduce the soil pollution. We go to the next link. So just now you have seen that how this soil pollution can reduce the fertility or quality of the soil. Now we see inefficient soil or crop management. If management of soil is not good, we will lose fertility. Or crop management practices are not up to the mark, we can lose fertility. So improper crop rotations means you are not rotating the crop, or rather you are not following the crop rotations, then it is going to decrease your fertility. Similarly, excessive tillage, too much of tillage can also reduce fertility. Besides this, there are many more practices, like if your water management is not good, you can lose fertility. Many times, farmers are using canal irrigation. In canal irrigated areas, sometimes they unnecessarily apply water, assuming that it will increase their yield. But at the same time, they can lose nutrients by leaching. They can lose nutrients by like nitrogen by denitrification. So many other practices also affect the fertility. So we need to have efficient soil and crop management practices. Now, restoration of soil fertility. Now, just now you have seen the reasons why soil fertility is going down. What are the reasons for its reduction? Now, how to restore it? So it is better just, if you know the reason, you can just put the reverse gear, and you can tell the restoration approaches. One is preventing the soil erosion, enhancing soil organic matter, correction of soil pH, salinity and alkalinity, and efficient crop management, efficient or proper tillage practices, efficient management of weeds, because weeds also remove significant quantity of nutrients, preventing soil, just a minute. Preventing soil pollution, you have seen the damage done by pollution, and restoring the soil biology. So these are 8 important strategies or plans to reduce or to improve the soil fertility. There can be many more things. Now, preventing soil erosion. How best we can prevent the soil erosion? If we are able to prevent it, then we can improve or at least reduce the reduction of soil fertility. Wind breaks, reduces the wind speed and has soil erosion. In BSc Agriculture, a course is taught on soil erosion, I think. So I think most of you know how to prevent the soil erosion. What are the strategies to control the soil erosion? There are different approaches like your agronomic approaches or cultural approaches are there, where you can include selection of crop. You can have strip cropping. You can have crop rotations. You can have intercropping of legumes. You can grow cover crops. So certain agronomic approaches are there. Certain agrostological approaches are there to prevent the soil erosion. What is agrostology? Agrostology.
The study of grasses.
Very good. So in particularly in hilly areas, one can plant grass or grassy way, grass planting can be done. That will prevent the erosion. It is a very important aspect. And there are a number of water management practices that can be done in hill areas to prevent soil erosion. Terrace cropping or terrace cultivation can be done. Or there are many more approaches. Integrated watershed management can result in reduced soil erosion. So there are a number of agroforestry measures or forestry measures are also there, which can help in reducing the erosion. Likewise, windbreaks, etc., can be used to terraces, cover crops, legume crop residues, organic manures. So one practice can affect many properties, like organic matter. It has multifarious role. It can reduce your soil erosion. It can increase microbial activity. It can increase your nutrient content. It can increase water holding capacity. So one practice you can find at several places, but overall its effect is in the improvement of soil fertility. So you will find organic matter everywhere. Even if you do mulching, that means you are adding organic matter to the soil. Of course, mulching for 2-3 months, it will remain on the surface. But after a few months, say 8 months, 10 months, it will decompose and it will become part of the soil. So this mulching can also be practiced to reduce the erosion. Enhancing soil organic matter. You need to enhance soil organic matter by stubble mulching, green manuring, compost, crop residue, addition of organic manure, and adopt efficient crops and cropping system that's sufficient organic to add sufficient organic matter into the soil. Crop rotations are important. Crop rotations here mainly thrust should be given on inclusion of legumes in the rotations. Conserve the soil and water by minimum till. Balanced fertilization is important. Necessary steps should be taken to preserve the soil organism. Means you should reduce the pollution, and there should not be water logging continuously for long time. It also reduces biodiversity. Correction of soil pH, salinity, and alkalinity. There are different methods to overcome such chemical adversities. Soil acidity must be corrected by adding adequate lime. Sufficient irrigation water should be applied to leach these salts. If you're from the saline soil. In saline soils, you can ameliorate them by leaching. Leaching is the option. For alkali soils, your addition of amendments like gypsum is the option. Adopt efficient tillage practices, planting salt-tolerant crops, correction of soil pH by soil amendments. So you need to add organic matter and correct the soil pH. Efficient crop management means include legume in the rotation and right crop rotations, and you can get deep-rooted crops. Deep-rooted crops are good. They can help in improving the fertility of the soil. Proper tillage practices, in this case, conservation tillage, minimum tillage, low tillage should be followed. And you know what happens in conservation agriculture? Crop rotations, mulching, and your no tillage. These practices are combined in conservation agriculture, so that improves your fertility. Then weeds should be controlled. It is necessary to control the weeds. As a student, you know that weeds remove a great quantity of nutrients. Therefore, weed management is necessary to conserve the nutrients in the soil. Preventing soil pollution, it is necessary to adopt the necessary strategies to control the soil pollution. The care should be taken to prevent the heavy metals reaching the soil through irrigation water, certain natural fertilizer, or city compost. So now you can see the role of organic matter. Organic matter in the last, you have seen preventing the soil pollution. So there are many strategies to prevent soil pollution. One practical option is addition of organic matter. Now you can see how organic matter can be helpful in preventing the soil erosion. In next 2-3 slides, you will see the role of organic matter in preventing the soil erosion. So I'm sorry, it is not soil erosion, soil pollution. The organic supplements and soil pollution, you can see. This figure tells you ecosystem function of soil organic matter and the process supporting them. You can see this soil organic matter. So what it is doing, you can see the yellow colored boxes. So water retention, it will improve the water retention or water holding capacity of the soil. Aeration, it will improve aeration by way of aggregation. By improved aggregation, by improvement in soil structure, it will improve the aeration. Aggregation, promotion of plant health. Soil organic matter promotes plant health by 2 ways. One is by supplying nutrients and other is by humic acid. You know, this organic matter is lastly converted to humus. Part of organic matter is converted to humus. Humus is made up of fulvic, fulvic acid, humic acid, and humin. So this fulvic acid and humic acid, they have growth promoting effect on plant. They can improve the plant growth, not as a nutrient, as a growth promoter. So promotion of plant growth, NPS mineralization. So mineralization of organic matter will give you nitrogen, phosphorus, sulfur, and other minerals. Carbon sequestration can also happen, and compound retention. It can directly retain certain compounds. So you can see a lot of interaction is happening. To try to understand this interaction, I can explain it, but it will take a lot of time to explain these interactions. You can see the arrow. For example, water retention and aggregation. They are protecting the soil. So likewise, you can see, and thus lastly, you see the effect of these yellows on greens. So ultimately, you will get erosion protection from organic matter. Soil biodiversity will be improved. Primary production will be improved. Climate regulation will be improved. and water quality will be improved. So overall, these organic supplements will have good effect on soil health, and they will, addition of organic matter will reduce the soil pollution. In the next slides, you will see how organic matter will reduce the soil pollution. So you see this cation exchange capacity will be increased if you add organic matter to the soil. Increased cation exchange capacity means it will hold heavy metals. So, and also this humus will be there, and humus will chelate the heavy metals, and it will be made unavailable or less available to the plants. So uptake by plant will be low. And then organic matter addition can reduce the aluminum toxicity. It can reduce the allelopathy, organic matter. There may be some allelopathy influence of one plant on another plant, or one chemical on the growth of other plant adversely is your allelopathy, you know it. So allelopathy effect can be neutralized, and then heavy metal toxicity can be reduced by organic matter. Increasing organic matter in soil increases the cation exchange capacity. This is important. At the same pH, plants from soils high in organic matter do not exhibit the symptoms of aluminum toxicity. pH is same, but in one soil you have more organic matter than the other soil. So effect of aluminum's toxicity will be minimized, reduced in soils where you have more organic matter. Aluminum is chelated by organic matter. This excess aluminum is chelated by organic matter, thus reducing the amount of aluminum in solution. Now, this is a very important reasoning question, that the pH of the soil is same, low pH, and where you are expecting aluminum toxicity, but in one soil you have higher organic matter, in another you have less organic matter. So soils where you have more or high organic matter will have less aluminum toxicity compared to the other. Allelopathy is adequate levels of soil organic matter neutralize the toxic chemicals, allelochemicals produced. So therefore, organic matter has so many roles in soil fertility management. Variety of roles are there. Organic matter reduces soil erosion. Eroded soil may contaminate the water bodies by pesticides and chemical pollutants. But organic matter retains heavy metals and nutrients which reduce the environmental contamination also. Organic matter constituents carry a negative charge and hence are able to absorb heavy metal cations. So then there are thousands of papers which prove that increasing organic matter level in soil is reduced effect of heavy metals on plant growth, as well as reduced concentration for human health also. Another advantage of organic matter in soil is absorption of herbicides. So you have two kinds of soil. One is clay soil, other is sandy soil. So in which soil you should apply more herbicide dose? You studied
Clay soil, sir.
on wheat. So in which kind of soil you need higher doses of herbicide? Yeah, just speak. Light soils.
Clay
Or
soil, sir.
which soil? Give complete answer.
Clay soil, sir.
In clay soil, you need to add more. In sandy soils, you need to add less. Why higher doses in clay soil?
So due to high
Due to high-
negative charges in clay soil.
Due to
Due to high pH, sir.
high?
pH, sir. Cation exchange capacity, it will be fixed.
Yeah, right. So in clay soils, you get higher cation exchange capacity. That means part of herbicide will be neutralized. That will not be used to control the weeds. So therefore, or will be made inactive, you can say, will be made inactive. So absorption of herbicide. So I'm not saying that, but somewhere if they are used in excess. So if agricultural lands are having low organic matter, applied herbicide may leach easily. This is another dimension. It may leach easily and contaminate the surface or groundwater. Absorption of herbicide on the soil organic matter should decrease its transport in the soil profile. So that is why it will prevent even the pollution of groundwater. Overall, the protective role of soil organic matter for plant lies in its high cation exchange capacity, you already answered, and the ability to form simple and chelate compounds with heavy metals ion in soil. So these are the 4 lines. It summarizes everything. The major role of organic matter is control of soil pollution. And also it will increase the population of the microbes that can digest or that can decompose the toxic materials. So that is also important. So overall, the protective role of organic matter for plant lies in its higher cation exchange capacity and ability to form simple and chelate compounds with heavy metal ions in soil. Now, restoring soil biology. Chemical pollution can reduce the soil biology. Your changes in water status can reduce the soil biology. The water logging can reduce the soil biology. And your monoculture growing one kind of crop year after year can reduce the soil biology. Addition of less organic matter can reduce soil biology. Your soil erosion can lose soil biology, or soil pollution can lose soil biology. So there can be many factors. Just go on thinking, and you can add the factors or things that will reduce the soil biology. And then you need to improve the soil biology. Soil biology here means biological properties of the soil, means you need to increase the number of organisms. And what can be done? Soil pH ideally needs to be close to the neutral range. Neutral range you will get maximum, because it is thought that if your soil is acidic, you will have more growth of. In acidic soils, what kind of microbes are prevalent? In acidic soils, what kind of microbes are prevalent?
Sir, mainly fungus.
And in basic pH, alkaline pH?
Actinomycetes, sir.
Actinomycetes, sir.
And which group of microbes have maximum population in soil? You have several groups of microbes. So which group has maximum number?
Bacteria, sir.
Bacteria.
Bacteria.
So you forgot the bacteria, I think. So what pH is loved by bacteria? I think actinomycetes are in,
Generally neutral pH up to 8.
generally neutral, means in general they prefer alkaline pH. They prefer, and they die or their growth reduce in acidic pH. Similarly, you will have less population of fungi in alkaline pH. So they try to, of course, you can start with neutral. So neutral to slightly alkaline or alkaline is loved by bacteria. So you need to have the ideal pH. pH between 6 to 7.5 is the best from all angles. This is the best pH of the soil. Sufficient supply of organic matter should be made, because they cannot multiply without food, and organic matter is the food. Minimum use of chemicals and pesticides. More chemicals, more pesticide, it will lead to their death. Minimum tillage enhances microbial activity. Crop rotation will enhance microbial activity. Soil compaction should be reduced, because soil compaction means your reduction in oxygen supply in the soil. So that will reduce the soil biology and inoculating the soil with microbes. Some external application can also be made to increase the population of the microbes. What will happen if we increase the fertilizer doses in the soil to microbes? Because it will act as a food to microbes also. So what will happen to the microbial population upon addition of fertilizers? I seek your answer.
Sir, increase their population.
What is others' view? What others think, other students think, because you are adding fertilizer, say NPK. Here fertilizer means mostly NPK. If you are adding fertilizer, that is a food for the microbes. So do you think that microbial growth will increase if you add fertilizers? In general, it will reduce. The microbial growth will reduce because they will directly get the nutrients. They will get the nutrients for their growth. They will get the food directly from the fertilizer. So many microbes can become lazy because why do they decompose the organic matter? They want food from the organic matter because inorganic food is limited. That is being taken up by plants also. So they attack the organic matter, and they are not doing this work for charity. They are doing it to get the food actually. So they decompose the organic matter to get the food. So if easily available food is there, so they will not work. And when they start working on the organic matter, they multiply very fast on organic matter. And therefore their population increases. So in general, your fertilizer application reduces microbial population. However, many soil scientists will not agree to it, but there are papers which suggest that addition of fertilizer reduces microbial activities.
Sir, but if they get enough food, then their growth will be more faster and they will reproduce more, sir.
Actually, these fertilizers will have some adverse effect on the growth of the microbe. Some papers suggest that even they will not work, they will not multiply if they get this easy food. So I reviewed this subject sometimes back, and if it is so, then I will review it again. I will come out with the correct answer. So at the moment, I cannot say what is the truth, but I will come back with the truth. Okay. I will share this answer on the email so that you will get the clear-cut things. But as on today, I assume that it is mostly means fertilizer application reduces microbial growth. But what are the reasons? I will search and I will share with you. Okay, Subrata.
Okay, sir. Thank
I
you.
do
sir.
not say, at the moment, I cannot say that you are wrong. I need to check it and I will come with the correct answer.
Okay, sir.
Okay. Now, lastly, you see, now soil fertility is over. This is what I wanted to start the soil fertility subject, and soil fertility and climate, because soil fertility will vary with the climate also. Under what kind of climatic conditions your soils are there. So soils of the humid tropics. What are the characteristics or what are the problems of humid tropics? What are the areas in India that you think are humid tropics? What are the areas in India that you think are humid tropics? Do we have any area in India that are humid tropics, states or regions?
Sir, northeastern Himalaya.
Northeastern Himalayan region. This is one. And you cannot say Himalayan regions. You can say Assam and nearby states. You can say, I think West Bengal also should be humid tropics. Your coastal areas should be humid tropics. You are young people, you should have geography and everything in your mind. You can tell me. So any other idea about humid tropics in India? This is true, this Assam and nearby areas, Odisha, West Bengal, and other coastal in the western Ghats. Wherever you have more water, more water and high temperature. That is the simple. More higher humidity and high temperature. That is humid tropics. So what are the areas in India where you have high humidity and high temperature? So simple now. So whatever they are there, you need to check. And then what are the, dry tropics? Dry tropics may be there. If humid tropics are there, where are the dry tropics? Any idea? अरे यार climatology पढ़ो आप लोग. You need to study.
Rajasthan.
हैं?
Rajasthan.
Rajasthan, Gujarat, part of Maharashtra should be there in dry, humid tropics. Sorry, dry tropics. And then there could be subtropical. One is tropical, other is subtropical, third is temperate. So tropical, you have divided into humid tropics and dry tropics, or maybe some other tropics. Similarly, subtropical is also there. So what are the areas in India which have subtropical kind of climate? Bolo bhai. Otherwise, you must read this subject. This is very, very important. You should know little bit of geography. What I suggest to you, today you take CBSE, you go to the CBSE website, find a geography book of 9th class. Will you mind reading 9th class textbook of geography? If you mind, you will know all these simple things. Up to what latitude you have tropics, and then subtropical, and then temperate, and so on. And you can get some idea of the areas of the land that are. So anyway, you read 9th textbook of CBSE on geography, and you will know everything. Very small book. So soils of humid tropics. So what is tropical subtropical areas in India are mostly in northwest plains. Northwest plains, your Punjab, Haryana, parts of UP and Delhi. These are subtropical areas. Bihar, subtropical areas. So you can check it. It's very rough line I'm drawing. And in temperate, you can have Western Himalayas. In temperate, you can keep it. Kashmir, Himachal Pradesh, you can keep partly in temperate, high hills. So you need to check it. So soils of humid tropics have some characteristics. They are acidic in nature, so liming is required. pH is 5.5 to 6.5, and they are low in available phosphorus. Some of you must be doing degree in Eastern India, in Assam and Jharkhand. So you must be knowing the level of phosphorus there. Iron and aluminum oxide and clay minerals, kaolinite dominate the clay fraction of highly weathered tropical soils. In highly weathered tropical, subtropical soils, aim is to raise and keep soil pH at a value where the plant available aluminum is reduced. So overall, you need to go for lime application. In these soils, much lower value of 0.1 to 0.8% potassium are found in old, deeply weathered tropical soils where the majority of feldspar, micas. So you can go through all these characteristics of these soils. Often have a slow sorption or storage capacity. So this is some extra part I am giving to you. You can read it. Often low in available nitrogen, although the decomposable organic matter is rapidly mineralized. You get sufficient moisture and sufficient temperature. So they are rapidly, organic matter is rapidly decomposed. Calcium deficiency is also widespread. Very low magnesium contents are observed in podzolized sandy soils, very acidic, strongly acidified forest soils. Soils of subtropics. Now see, water shortage is there. So without irrigation, fertilizer use must be suitably adapted to efficient water use. Nitrogen being the main critical nutrient on account of the low humus content, low organic matter content in subtropics, neutral soil reaction, therefore often a shortage of available iron and zinc. Or you can't say neutral, you can say neutral to alkaline reaction. A generally good supply of sulfur, manganese, and boron, and risk of salinity is there. Soils of the humid temperate zones, widespread soil acidity which requires liming, some having obstacles for root growth, hard layers in subsoil, often insufficient aeration, generally shortage of available NPK. low nutrient reserves in sandy soils. Some soils fixed E and molybdenum. So you can overall go through this. I will share you shortly this presentation. So overall, this lecture suggests that decline of soil fertility happens due to several reasons, mainly erosion, nutrient depletion or mining, soil degradation, physical degradation, loss of organic matter, reduced biological activity, soil pollution, and so on. Strategies are available to overcome. We already discussed the strategies to improve the soil fertility or restore the soil fertility. It is known as restoration of soil fertility, maintenance of soil fertility, and improvement in soil fertility. You can use either of these: restoration, improvement, maintenance, upgradation of soil fertility, etc. So different names can be given. There are several limitations or issues pertaining to soil fertility under different climatic conditions. So I gave you some suggestions, some points, and I could not discuss all in detail that how many of these are practical. But as a student, this is for the students' knowledge. And I discussed this lecture, but many practical aspects are missing in this lecture that you need to consider yourself. Because for the students, we need to talk more of academic than practical things. So because besides knowledge, you need to transform this knowledge into papers in your competitive exam, in your regular class exams, and so on. So from that angle, this is perfect. You can get some questions in future, any exams, so you can give answer very well. Now we have 6 more minutes left, but for 1 minute, next 1 minute, I wish to take a lecture on any day. Tomorrow is Wednesday, Thursday, Friday, Saturday, Sunday. So you have 4 days. In these 4 days, I request you to give time for one lecture of about total 2 hours. Maybe tomorrow, day after tomorrow, or Saturday. I would prefer Saturday, but it is up to you. From my side, it is Saturday, 5 to 7 in the evening. First thing is that you should agree to it. Second thing is time. So now I stop recording, and then you give